You got your final tomorrow or the next day?
The next day.
Okay. Well, I do have spots open tomorrow if you need them also.
Okay, awesome.
So you're going to verbalize some stuff tonight?
Yeah. Just a lot of review, so.
Okay.
Mostly properties of radicals.
Okay.
But, yeah. So the first one, says simplify the expression, the square root of 9a to the power of 3, b to the power of 3.
Okay. Let's take each of these separate. In other words, whenever you have these, do it number or variable one at a time.
Okay.
So let's talk about taking the square roots of variables like that. What's that going to be equal to?
Would that just be a times a times a?
Well, more importantly, it's the square root of a squared times the square root of a.
Okay.
Okay? And now what's the square root of a squared?
The square root of a, and the square root of a.
No, what's this? That's just a.
Oh, just a. Just a, right?
Right. So now that simplifies to a times square root of a.
Okay.
If I had a to the fifth, what would it become?
A to the power of.
Right. You always want to bring out the even powered.
Okay.
I know what that is. What is that?
That's a to the power of 2, which is
times the square root of a. In other words, that's how we do variables.
Okay.
Okay? So, back to your problem. Do it one at a time. What's the square root of 9?
3.
What's the square root of a cubed?
It's going to be a to the second.
No, just a
No.
square root of a.
Okay, my bad.
Okay? And what's the square root of b cubed?
B to the square root of b.
B square root of b. Now we can combine anything that's got the square root sign and put it together. So we, excuse me.
Bless you. Bless
We
you.
end up with 3ab times the square root of ab. You see how we get from this to this?
Okay, so just combine everything that's out of the square root and the square root.
That's the way you do all of these. Okay, what else you got?
The next one says, what's the sum of 9 to the square root of 3 and 7 to the square root of 3?
Well,
My bad, not to the power, my bad. It's like 9 to the square root of 3.
I knew it was wrong because you couldn't do anything with that. What is it again?
9 square root 3 and 7 square root 3.
Like this?
Mm-hmm.
Okay. These are both apples. That's an apple.
Okay.
I got 9 apples and 7 apples. How many apples do I have?
Sorry, 17? No. 16.
And the apple is square root of 3.
Okay.
Okay? So as long as you got same things, you can add them and subtract them. If this is square root of 5, I can't do anything. Because now this is an apple and that's an orange.
Okay.
So as long as...
So you don't
Go ahead.
Sorry. You don't do 16 square root of 3, you just do 16.
No, 16 square root of 3.
Oh, my bad.
In other words, I got 9 apples there. I got 7 apples there. I'm ending up with 16 apples.
Gotcha.
And it doesn't matter what this is. That could be root 5, as long as it's an apple. In other words, as long as it's the same thing, then I can add them and subtract them.
So, if there was a problem like that, but there was, let's say it was the exact same thing, except there was no 9.
Like that?
Uh-huh.
That's one apple.
What answer?
That's one apple, and 7 apples would be 8 apples.
Okay.
Always remember there's a 1 in front of those, even though it's not
Okay.
written.
Okay. The next one says solve 5x plus 9 in parentheses to the power of 2 equals 110.
110?
Uh-huh.
Okay. What's the first thing you'd want to do here?
Square the 5x plus 9.
Actually not. That's
Okay.
what most people want to do.
Root?
Yeah, that's what most people are inclined to do. But there's a much quicker way to solve this problem.
Is it square root?
Yes, take the square root of both sides immediately.
Okay.
What's the square root of the left side?
5x plus 9.
What's the square root of the right side?
Don't know. Let me get out my
No,
calculator.
I don't want a decimal. What I really wanted was the plus or minus.
Okay. Plus or minus.
Whenever you're solving an equation by taking the square root of both sides, always begin your answer with the words plus and minus.
Okay.
And that's how I'm solving this equation. So I'm taking the square root of the left side and the square root of the right side. I don't care what the square root of 110 is. I can write it like that. There's no problem writing it like that. But now let's continue to solve it. What's the next step?
Just subtract 9.
Okay, so now I got 5x equals minus 9 plus or minus the square root of 110. Now what?
Divide by 5.
So x equals that. Notice.
Okay, so you don't actually simplify to a decimal or anything.
Well, I might be able to simplify 110. I don't know. I have to think about it. But what I was going to say is notice how much that looks like a solution from applying the quadratic formula. And that's because it could be solved that way also. We could apply the quadratic formula. Had we expanded this out and turned it into a quadratic and moved the 110 to the left and then have to apply the quadratic formula to it, we're going to get this answer.
Okay.
Okay. Now, can we simplify that?
I don't think so.
No. In other words, if I look at my perfect square numbers, that's the only way you can simplify something is if it's divisible by one of these perfect square numbers.
Right.
And I can tell by now, after looking at just these, that none of those divide evenly into that number. 4 doesn't.
Okay.
9 doesn't. 16 I don't think does. 25 doesn't. 36 doesn't. 49 doesn't. And there's no way 64 could because it's more than half.
Okay.
So I know it's simplified.
Gotcha.
And it's worth stating that this means that the first solution I use the plus sign, the second solution I use the minus sign. Okay? So the first solution would be minus 9 plus root 110 over 5. The other solution is going to be minus 9 minus root 110 over 5.
Okay.
That's what that plus minus means. You have two solutions. One has plus, the other is the minus.
Gotcha.
Okay. Notice how much easier it was to do it this way.
Yeah, compared to
expanding that out and then having to apply the quadratic formula, which you would. In other words, whenever the solution is an irrational number like that, it's not going to factor. We know that it won't factor just by looking at the solution we came up with. So this is tremendously quicker and easier than expanding and applying the quadratic. find the same result. So always look for that. If you can solve an equation by taking the square root of both sides, that's usually the simplest way to do it. In other words, if I say x squared equals 25, I don't need to factor that or anything. I just need to take the square root of both sides. So what's the answer?
5.
Plus or minus 5.
Oh, right, my bad.
It's okay. You're not the only one that does it. I do it too. I did it earlier today. I did it and then I couldn't believe I did it because I tell 95% of my students over and over and over, do not forget the plus or minus sign.
Right.
If I could tie a string around somebody's finger, I would. Seriously. I don't know how to get people to remember it. I mean, if I could teach them a little song, you know, sometimes I'll teach you the quadratic formula by teaching you a song, kind of like the ABCs, how you learn the ABCs.
Yeah, that's what we did in class, but it was like the
that worked.
I'm
not against that solution. It works. But you just got to figure out your own way to memorize stuff. That's kind of unique to every individual. I have my ways, but it's not always the same as everybody else's way. What else we got?
Okay, this one says complete the square for x squared minus 14x plus blank. Okay.
How do you complete?
And it's then right there. So
how do you complete the square?
Don't you take like the square from each side?
Actually, you take half of the coefficient of the x term.
Okay.
Square it and add it. So what should be added?
Okay, so 7 times 7, right? 49?
49. Now, why would I want to complete the square? Is because now I can write that thing as x minus 7 quantity squared. And that's what they wanted you to do. That was the second part of your problem, right?
Okay.
And that's always the reason we complete the square. If we're trying to turn something into a linear factor squared, you do it by completing the square.
Okay.
Now, let's make it a little more practical. Let's say that that whole thing was equal to 10. And I want to solve this by completing the square. Well, I'm going to complete the square on the left side by adding 49. But I can't add 49 to the left unless I add 49 to the right. So I'm going to add 49 to the right. Now I can write the left as a linear factor squared. Now I can solve these pretty easy by just taking the square root of both sides, right?
Right.
So x minus 7 equals plus or minus the square root of 59, which makes x equal to 7 plus or minus the square root of 59. So that would be the solution. So this might be an easier way to solve this problem rather than the quadratic formula, because remember, this is what we started with. Okay, well, if you were to try to solve this in the normal way, you'd bring the 10 over here, leaving 0. You'd try to factor it. It's not going to factor, and then you'd have to plug it into the quadratic formula. So there's multiple ways of coming up with these solutions. And by multiple, I mean more than 2. You know, you can put it in standard quadratic format and go that route, or you can complete the square and go that route. Either route works for solving these.
Okay.
This one, they didn't give you an equation. They just gave you an expression and wanted you to complete the square and then put it in this format. Okay. So complete the square on this for me.
Okay, so take half.
Don't multiply
Okay,
it.
so
Take half and square it.
okay, so 25.
Okay, now write that as a linear term.
X minus
It's always
5.
whatever you got when you took half of that.
Okay,
Always what.
got it. Okay.
All right. Now, you got to be a little careful. I don't know how hard they're making their complete the square problems, but you stick a coefficient in front of that and it changes everything.
Mhm. And
In other words, if I said complete the square here, you've got to factor out that 2 before you can complete the square. In other words, this becomes this. And now I can complete the square on the inside if I want. I'd have to take half of 3, which is 1.5, square it, which is 2.25, and add it. Okay, now I can write that whole thing as x minus 1.5 quantity squared.
okay.
Okay, so it becomes a lot more difficult if there's any number greater or different than 1 in front of the x squared. You can only complete the square if the coefficient of the x squared is 1. So you have to do whatever you have to do.
Okay. On my study guide, they don't have any examples of that.
Okay.
Or any problems like that. So I don't know if it's going to be on there.
Right. Let's not worry about that then.
It's good to know that, just in case.
Yeah.
Okay, the next one says find the roots of r squared minus 12r equals 28.
Okay. Well, like I said, there's multiple ways to go here.
Okay.
How would you proceed? Which way works for you best?
Would you want to square root the r? The left side and the right side?
In other words, it doesn't do any good to take the square root of that. I don't know what the square root of that is.
Good point. And the other ship's going to be a decimal.
Well, no. It's that I don't know how to, you can't take the square root of that. Okay? So I got two choices. I can complete the square and go that route.
Oh, okay.
Or I can subtract the 28 from both sides, putting it in standard format. In other words, I got two choices. I can do this. Now I can try to factor it. And if this factors nicely, I'm home free, but I don't think it does. 14 times 2, yeah, it actually does. In other words, if it factors, into whole numbers, then that's the easiest way to solve it.
Okay.
Notice that that does work. The middle term comes from the insides and the outsides, plus 2r minus 14r equals minus 12r. So it's factored properly. Now what are the solutions?
R equals -2 and equals 14.
Right. In other words, you set each one of those equal to 0 and solve.
Okay.
So I guess it's not easy to tell. Let's do that same exact problem, only this time let's do it by completing the square. Because had it not factored right, it would have been far easier to do by completing the square. Let me just prove to you that we're going to get the same answer. So how do I complete the square?
Take half of the 12, which is 6, and multiply it by 2, which is
square it. Square it. So what's that?
36.
Okay, so I'm going to add 36 to both sides, since that's all I'm allowed to do. And then I can now write the left side how?
R minus 6 squared. My bad.
Equals 64. Now take the square root of both sides.
Okay. It's going to be r minus 6 equals 8.
What do you have to do every time you take the square root of both sides of an equation?
Plus or minus 8.
There you go. And notice that's going to matter. Okay, now I
Right.
got to add 6 to both sides, so that's what r is equal to. Well, that gives me two solutions. 6 plus 8 is 14. 6 minus 8 is minus 2.
Okay.
So if it doesn't factor nicely, completing the square is the easier way to go. If it factors nicely, I don't know. It might still be the way to go. This was pretty easy to do by completing the square.
Great.
Whereas factoring it might have been harder for you to factor that.
Oh, so it just like depends on the situation.
Well, it does. It depends on the quadratic, and it depends on whether it factors, and it depends on how good you are at factoring. In other words, completing the square always works. Always. For solving a quadratic. Okay. It's just a completely different way to do it. But you get the same solutions.
Right.
All right. What else?
Okay, this one says find the number and type of solution for x squared plus 6x equals negative 9.
And it says what? Find
the number and type of solution.
Okay. That means analyze the discriminant.
Okay.
Quadratic formula. They actually give this thing inside the radical its own name, and it's called the discriminant. And the reason they give it its own name is because you can use it to figure out what kind of solutions you're going to have.
Okay.
If what's inside the radical is a negative number, we got problems, right? We're going to be taking the square root of a negative number. So
Right.
if b squared minus 4ac is negative, we're going to have two complex solutions, imaginary.
Okay.
If this is a positive number, well, then we're fine. We're going to have two real solutions. If it's exactly equal to 0, we're going to have just one real solution, because this will go away and we'll just have minus b over 2a. So the key to answering this problem is to analyze that. Well, what's a, b, and c?
A is x.
The coefficient of x squared is what a is.
1.
Huh? What's b?
Okay.
It's the coefficient of x. And c is the number if it were in standard format.
So if we just add 9 to their side, then...
You got it. So c is plus 9.
Okay.
So now let's analyze the discriminant. What's b squared minus 4ac?
Okay.
36.
So it's going to be...
Minus 4 times 1 times 9, and I would always suggest you do it like this. Don't do this in your head, because a lot of times there's going to be a negative sign attached to one of these.
Okay.
And then it's going to matter. Well, this is easy enough to do, but I would always multiply the 4, the a, and the c together first, as your first step in solving this. Well, that's 36, so we have 36 minus 36, so the discriminant is 0. That means we have one real solution. And we don't need to worry about taking the radical. In other words, I don't care about the rest of it. I only care about what that is. If it's positive, 2 reals. If it's negative, 2 imaginary. And if it's exactly 0, 1 real.
Okay. Okay. Next one says find the zeros of the function. H h of x equals x squared plus 29x plus 100.
Is that 29 or 21?
29.
Plus 100?
Yep.
Okay. So if we were going to try to factor that, what would we be looking for? Factors of 100 that do what?
Add to 0? No.
29.
29.
In other words,
okay, yeah.
If I'm going to factor this, in other words, when you say find the zeros, it means setting it equal to 0. Because that's the zeros is when h of x is 0. That's when this function crosses. In other words, this function is going to look something like this. Okay, it's going to be a parabola. Well, where do the zeros come? They come where y is equal to 0.
Okay.
That's why we set the whole thing equal to 0 and then solve it.
Okay.
Okay. So the question is does it factor nicely?
Okay.
Factors of 100 that add to 29. Well, let's look at factors of 100. I'm not sure I've ever taught this little technique to you. I just kind of discovered it recently. It works kind of nice. If I'm looking for factors of 100, start with 101, and then cut this in half and double this. Do it again. I can't do it anymore, but I can cut this in a fifth and multiply this by 5. That makes 5 and 20.
Okay.
Okay. Now I can, that might be, no, we got 10 and 10.
5 and 4?
I can double this, half that. Right?
Okay.
So that's one way to find factors, is to do that. You don't always have to take half and double. Sometimes you can take a third and triple, or like here I took a fifth and multiplied 4 by 5. As long as you do the same thing to one of the factors as the opposite of the other, it's always going to work. Well, do you see any of those factors that add to 29?
25 and 4.
So the zeros are where?
X equals negative 4, and x equals negative 25.
You got it.
Okay. Okay, the next one says solve 36x equals negative 4x squared minus 50.
Okay. How are we going to do this?
Are we gonna square root the both sides or not?
Notice that the only time that works is if it actually gets you somewhere. I can't take the square root of that. I don't know how to do it. It doesn't reduce.
Can you add 50 to both sides and then square root?
Typical, well, you could actually get this on the other side and complete the square, but the standard way to solve a quadratic is to get everything on one side, 0 on the other.
Okay, so add the 4x square root.
Well, since we want a positive coefficient instead of a negative one, let's move these two terms to the other side. Instead of moving the 36 to the right, where everything would be negative, let's move these two to the left and make everything positive. So now we have 4x squared plus 36x. Let's put everything in order. So that's the same thing, right?
Right.
All right. Now, it's harder to factor when we got a coefficient in front of the x squared. It just is. It goes from a degree of difficulty of 2 to a degree of difficulty of like 6.
Okay.
So anything we can do to reduce this, we want to do.
Okay.
Well, I can certainly divide everything by 2. be nice if I could divide every term by 4, but 4 doesn't go into 50. However, I can divide both sides of the equation by 2. So I can knock it down a tad. Well, when I divide the right by 2, I still get 0. So now I have to solve this equation instead of this one. Well, let's try to factor it. Remember, you can always immediately go to the quadratic. But the quadratic is pretty hard, and factoring isn't that hard, so if you can factor it, that's usually the way to go. Problem is there's kind of a fine line. If you spend 5 minutes trying to factor it, and you can't factor it, then you have to go to the quadratic. You'd have been better off going to the quadratic immediately, right?
Right.
So that's what we don't know. So I don't really know what the proper method here is. It depends on how good you are at factoring. So let's give it a shot, a quick shot at factoring. What's going to go here and here?
X and X, or no?
You got to split that up so that the two terms multiply back to give you this.
2x and 2x?
Well, what would that give you if I did that?
Be 4x.
So how about 2x and x?
Okay,
multiplies back to 2x squared. And you always want to make that step. In other words, once you start factoring it, make sure that these multiply back together again. I can't tell you how many students I have that they split it apart and they don't bother to check whether it multiplies back to give you that. Okay, so the signs I know, they're both plus.
Okay.
And it's worth giving a shot at 5 and 5, right? Factors of 25. Let's see if that works. Doesn't.
Okay.
So I got one other choice. I could do 25 and 1. That doesn't work either. That gives me 27 in the middle. There are no other factors to 25 besides 5 and 5 and 25 and 1. That's it. There's no two other numbers that multiply to give you 25. Therefore, doesn't factor. Go directly to the quadratic formula. What is it? Do you get a cheat sheet, or do you have to memorize all this stuff?
Oh, we're supposed to memorize it.
Okay, what's the quadratic?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2b, or 2a, my bad.
Right. Okay, what's a, b, and c here?
A is 2, B is 18, and C is 25.
Okay. So plug everything in. What do we got?
Okay, so negative B, my bad, negative 18 plus or minus the square root of 18 squared minus 4 times 2 times 25 over 2 times 2. 4.
All right. And you have to do the arithmetic at this point. I mean, you can do it with a calculator, but that's the next step. I don't know if you want to spend time doing that, or you want to go to the next problem.
I go to the next problem.
Okay. There may be some simplification of this once we get down to a number inside that radical. And that's something you need to be able to do, is simplify radicals.
Okay.
And let's just try to simplify. What's 18 squared minus 200? In other words, this is 200 here. What's 18 squared?
Okay. 324.
Minus 200 gives you 124. So now we're going to have minus 18 plus or minus the square root of 124 all over 4. And I'm glad we did this because that you can simplify that. Is 124 divisible by one of those perfect square numbers?
I don't think so.
Any number is divisible by 4 if the last 2 digits are divisible by 4.
Oh yeah,
So
it's 31.
24 is divisible by 4. That means the whole number is divisible by 4. Okay? So square root of 124 would be square root of 4 times whatever's left when you divide it into it, which is 31, which means it simplifies to 2 root 31. So let's go back up here and change it to 2 root 31. And now there's one last simplification you can make. What can I do to that whole thing? I can divide top, and everything's an even number.
You can divide
except the 31, but I don't care if that's odd.
Okay.
What I'm going to do is divide the top by 2 and the bottom by 2. Turns the top into minus 19, minus 9, what am I thinking? Plus or minus, this 2 goes away, and the bottom becomes 2 instead of 4. You see how this turns into this?
Mm-hmm.
And necessary to do. You would lose points if you gave that left one as the answer. Because they want you to simplify it as far down as you can. They don't want you to turn it into a decimal. This is the proper answer here.
Right.
They just want you to simplify. Just like you'd lose credit if you gave the square root of 124 as an answer. Because that can be reduced. That can be simplified. So you can see how difficult these problems become, particularly if you don't know whether it's factorable or not. And a lot of times the only way you know if it's factorable is to sit and try a bunch of trial and errors. So, I don't know. If you're taking a test and you had a limited amount of time, I'd be tempted on a problem like this to go directly into the quadratic formula, especially if you know it well.
Okay.
I don't know. That's something I can't really say. It really kind of depends on how fast you can figure out whether it's factorable or not. And that's not always something that people can figure out quickly. If I said factor this to a lot of students, some of them might spend 20 minutes trying to factor it before they come to the conclusion that it's not factorable. You have to go and use the quadratic. So, and that's not a ding on those students. It just means it's hard to factor. You know what I'm saying?
Right.
It's actually easier to use the quadratic formula if you know it.
Mm-hmm.
Unless it does happen to factor easily. All right, what else you got?
Okay. It says it says solve 3 square root of 4 minus.
I didn't quite hear that. What was it?
Oh, sorry. 3 square root of 4 minus x, and outside of the square root is minus 11 equals negative 5.
Okay. When you have an equation that has a radical in it, the entire goal is to isolate that radical with the intention of squaring both sides once we do. Okay? So, let's go through what are the steps going to be to isolate that radical.
Plus 11.
Okay? So now I got, what next?
divide by 3.
Okay.
And then you square both
Yeah,
sides.
when you're solving an equation by squaring both sides, you don't have to worry about the plus or minus. It doesn't come into play.
Okay.
I'm just going to square both sides like that. So x has to equal 0.
Okay.
In other words, if I get minus x equals 0, so x is equal to 0. But even if I move the x to the right and the 4 to the left, I get x equals 0. 0 equal x.
Okay.
Does that make sense? Well, if x equals 0, we have 3 times 2, 6 minus 11 equals minus 5. Yes, it does. In other words, it's always good to take your solution and plug it back into the original formula to make sure that it works.
Okay.
Although you don't generally have to when you're dealing with radicals. Well, sometimes you do. Depends on whether there's 1 or 2 radicals in the equation. What else you got?
Okay. It says find the inverse of f of x equals 8x plus 9.
Okay. First thing to know is that f of x is the same as y.
Okay.
There's 2 things you have to do to find the inverse. It doesn't matter which order you do them in. The order I like to use is switch the variables and solve for y. Those are the 2 things. That's all you have to do.
Okay.
So switch the variables first. What's that give you?
X equals 8y plus 9.
And now solve that equation for y.
Okay. So you put in 0 for x.
Oh, no.
Yeah.
Just solve that for y. In other words, get it to where y equals something.
Oh, okay. My bad.
Isolate the y, in other words.
Okay, so plus the, or no, I guess we can just do minus 9. X minus 9. Then we just divide both sides by 8.
There's your inverse.
Okay.
It's that easy. Okay.
Okay.
Just know that f of x is the same as y, and then switch the variables and solve for y. I would do it in that order always. I mean, you can solve for x and then switch the variables, but there's no reason to do it both ways. Always do it the same way. Switch the variables and then solve for y.
Gotcha.
All right.
Okay, the next one says evaluate a to the power of -1, b to the power of 0, and it says for a equals 3 and b equals -1.
Okay. So they want 3 to the minus 1. What's that equal to?
0?
No. What negative exponents mean are merely move the thing to the other side of the fraction bar and change its exponent. So that's actually equal to 1 over 3 to the 1 power.
Okay.
Okay? This anything to the 0th power is equal to 1, no matter what it is, including 0. 0 to the 0th power, believe it or not, is equal to 1.
Okay.
So did we answer the question? It was 2 separate expressions they wanted you to evaluate?
No.
And evaluate it when A was equal to 3
and b was equal to -1.
-1.
Yeah, my
It
bad.
doesn't really matter what B is equal to. As long as it's being taken to the 0th power, it's equal to 1.
Okay.
Okay? In other words,
Gotcha.
A million to the 0th power is 1. Minus
Gotcha.
a billion to the 0th power is 1.
So that would just simplify to 1/3, right?
Well, I wasn't sure. Was it a to the minus 1 plus b to the 0?
Yeah.
Yes, okay. So that was 1/3 plus 1 simplifies to 4/3 or 1 1/3.
Okay. Gotcha.
Okay.
Okay, the next one says simplify, in parentheses, w to the power of 7, c to the power of 5, end parenthesis, new parenthesis, -8 times, -8w c to the power of 3.
Like that?
Mm-hmm.
Okay. Again, do it one thing at a time. Do the numbers first, the letters W next, and then the letter C after that.
The numbers, and the letters? No.
The only number there is -8.
Okay.
What's the
Then you
exponent
do the exponent
on the W? What is W to the 7th times W equal to?
W to the 8th.
Correct. Now
Okay.
do the C. What's the exponent of C going to be?
It's gonna be c to the power of 8.
Uh-huh. That's all you do on
Okay.
those, is just do them one piece at a time. Just
Gotcha.
biggest problem is realizing there's a 1 right there. In other words,
Okay.
a lot of people multiply W to the 7th times W and come up with W to the 7th. You got to remember there's a 1 there, and you got to add the exponents.
Okay.
And the -8, it wasn't -8W cubed. That would be a different.
No.
That would be a different story. Then you got to cube -8. It depends on where the parentheses are. If I remove those parentheses, different expression. Now it's -8 times W cubed. Whereas if I put parentheses, it's -8W, all of it cubed. So I would have to cube the -8 and the W. So parentheses make a huge difference when you're dealing with exponents. And if there's none there, the exponent always only applies to what it is on top of. Okay? In other words, if I give you this expression, 26xy cubed, the cube only applies to the y. It doesn't apply to the x. It doesn't apply to the 26.
Okay.
If I do this, now the cube applies to both the x and the y.
Gotcha.
And of course, if I put the parentheses around the 26, it applies to all 3.
Okay. Okay, the next one says, write the expression 27 to the power of 2/3 in radical form, then evaluate.
Okay. Fractional exponents. The denominator is the root. The numerator is what you take it to that power. In other words, this is the same thing as the cube root of 27 squared. That's what it means.
Okay.
Okay? But it always makes sense to take the bottom first. In other words, I don't want to square 27 and get some big number, which I won't know how to take the cube root of without a calculator. So, and they generally want you to do these without a calculator. That's because this always ends up being a small whole number. What's the cube root of 27? And if I told you the answer is either 2, 3, or 4, what is it?
4.
Oh, it's 3. 3 times 3 times 3.
My bad.
Right.
My bad.
That's all right, but it's useful to know, and these are always going to be small numbers when you take the root of it. I've never seen one where it was 6 or even 5. It's always 2, 3, or 4. Okay? So, in other words, that's the same thing as 3 squared.
Which is 9. Okay.
So let me give you one. Let me make one up.
Okay.
What's 8 to the 2/3?
Okay, so what goes in 3 times? Or, yeah.
No, what multiplies 3 times by itself to give you 8? What small number? It's either 2, 3, or 4.
It's 2.
2.
Right.
2 times 2 times 2 equals 8. That means the cube root of 8 is 2.
Okay.
And now we got to square it because of this. So it's 2 squared, or 4, is the answer. And like I said, they're always going to give it to you where this root is a whole number and it's a small number. They're not usually going to give you this even, because most people don't know the cube root of 125. It happens to be 5, so that would be 5 squared. But they're just not going to give you this big of numbers where the cube root is 5. The ones they give you, the cube root is always going to be 2, 3, or 4. But it's worth knowing, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So it goes up fast when you're cubing it.
Right.
All right, what else you got?
Okay, it says simplify the expression square root of 16, a to the power of 3, b to the power of 3. That's all under the square root. So.
Okay. So it's very similar. We had one at the very beginning that was 9 instead of 16. But it was the identical problem. In other words, the problem we started out with was this one. Remember?
Yeah, I think so.
Okay, so how do we do it? What's the answer going to be? Do it piece by piece. What's the square root of 16?
8. No, oh my gosh, 4.
What's the square root of a cubed?
Square root of a.
And what's the square root of b cubed?
B square root of b.
Now put them all together. We can combine the radicals, and we can combine.
Oh, right. So 4ab square root of ab.
You got it.
Okay, got it.
What is the square root of a to the 7th?
Let's see. That'd be a to the power of 4. Right?
Always take the highest even number.
Okay, so a to the power of 6.
Well, it's this. And then what's the square root of a to the 6th?
A to the 4th?
A to the 3rd. It's just half of that exponent.
Okay, so you don't take an even number for the second.
No. In other words, this is a to the 6th because a to the 3rd times a to the 3rd is equal to a to the 6th. That's why the square root of a to the 6th, you just cut the exponent in half.
Gotcha.
The square root of x to the 10th is x to the 5th. Now, tell me if you've seen anything like this, because this can be a little tricky. What is the cube root of a to the 4th?
I've seen that.
You have?
I don't know if I have or not. I don't think I have.
Well, we'd do it similarly. We would make it the cube root of a cubed, because I know what that is, times the cube root of a. The cube root of a cubed is just a, so the answer would be this. A times the cube root of a.
Okay.
So if you're doing cube roots, you handle this a little differently. You
Okay,
pull
yeah.
out the highest multiple of 3, not multiple of 2. When we're doing square roots, you pull out the highest multiple of 2. But if I was doing the cube root of x to the 10th,
Mm-hmm.
I'm going to pull out the highest multiple of 3, which is x to the 9th times x. And what's the cube root of x to the 9th?
X to the third? No.
There you go.
Oh, it is? Okay,
Huh?
yeah.
Because x to the third times x to the third times x to the third equals x to the 9th.
Right, I forgot you add...
Right, you add
exponents
exponents when you're cubing stuff or squaring stuff, but when you're taking cube root, you basically are going to divide this exponent by
Okay.
to come up with that.
Okay.
Okay? We don't really want to deal with that if you're not going to see it on a test, but I thought you might end up seeing that.
Okay. I have one more problem.
Okay,
so.
let's do it.
Okay, it says solve 4 to the power of x minus 4. Like, no, sorry, x, yeah, there you go. Equals 64 to the power of x.
Okay. When you have an exponential equation like this, and I call it an exponential equation because the variable is in the exponent. It's not algebraic anymore. I can't use algebra to solve this. But there happens to be something in common between 4 and 64. They have a similar exponential base. I can leave the left the way it began, but I'm going to write 64 as 4 cubed. So I haven't changed anything. Now I can apply the power of exponents, my rules of exponents. If 4 to the x minus 4 on the left, what's this on the right become?
4 to the third of x?
No. 4 to the 3x. In other words, when you're doing double exponentiation, you multiply the exponents.
Okay.
So that's the same thing now. Now I got the same base. It's 4. Well, if 4 to this exponent equals 4 to this exponent, the exponents have to be equal. So I can say x minus 4 equals 3x.
Okay.
Solve that, and you get 2x equals minus 4, x equals minus 2.
Okay.
So whenever you're looking at that exponential, look for a common exponential base. Before I let you go, I'm going to give you one more of those just to see if you got it.
Okay.
I'm going to make it tougher. How can I solve this for x?
Would it be, for the first one, 3 to the power of 2?
Always put parentheses around it. In other words, I'm writing 9, I'm just writing it in this way.
Okay. And then, yeah, x minus 4 equals, 3 times the power of 3.
Now, multiply both sides.
Okay, so, 3 to the power of 2x minus 4.
Minus 8.
Oh, my bad, minus 8.
Multiply that by that. That's why I said put parentheses around it.
Okay, my bad. Equals to the power of 3x.
Okay, now you can equate exponents.
Okay.
In other words, the next step is 2x minus 8 equals 3x. Now that's easily solved.
Okay.
So it isn't always the same number like the problem you gave me where it was 4 and 64. Sometimes the common exponential base is less than both numbers. Like this case, the common exponential base wasn't 9. 9 is a common factor, but that's not what you're looking for. You're looking for a common exponential base, which is 3.
Okay.
Okay? Connor, I hope that works for you.
Yeah.
Like I said, if you need another session, I got lots of available slots tomorrow. But
Okay.
sounds like we've gone through all the problems, so you might be in pretty good shape.
Yeah.
Good luck on your test, and if I don't talk to you again, have a good summer. I'll
Awesome. You too.
maybe work with you next fall again.
Yeah, of course.
Okay?
Awesome. Thank you so
Have
much.
a good one. Bye-bye.